Okay, this is lesson 15. We have a warm-up question. You can pause this video and try these problems on your own and then check with my answers, or you can follow along and take good notes and pause the video as needed. All right, we have, here's an inequality. The opposite of x is greater than or equal to -4. Without testing any values, predict what the solutions to this inequality will look like on a number line. So if I'm thinking about a number line of a value, the opposite of x being greater than or equal to -4, I have to first of all think about that negative sign. So I would make sure that if I'm doing the opposite of x is greater than or equal to -4, that means I'd be dividing by -1, which also means the opposite. When we divide by a negative, that means x is going to be less than or equal to 4. So in my mind, I would have a picture of the number 4. I do have an equal sign in there, so I know it's going to be shaded in. And x is actually going to be less than 4 because we're told that the opposite of x is greater than or equal to -4, which means the opposite operation in terms of inequality, and then also opposite of the number. Okay, will the circle at that point be filled in or unfilled? Well, we kind of already did that there, so we're going to say it's going to be filled in because it includes it. Will the shading go to the right or the left? Well, less means to the left. That would be shading to the left. Okay, test each value to see whether it is a solution to this inequality. Of course, we went ahead and solved this inequality as x is less than or equal to 4. So is 3 less than or equal to 4? Yes. Is -3 less than or equal to 4? Yes, it's less. Is 4 less than or equal to 4? Yes. Is -4 less than or equal to 4? Yes. Is 4.01 less than or equal to 4? No, it's greater. Is -4.011 less than or equal to 4? Yes. So once you solve it, these other questions become easier. You don't have to plug them all in here to work them out. All right, it says graph all possible solutions to the inequality on the number line. Well, we're going to put our solution answer of 4 in the center, and it's going to be a closed circle. Ordering our number line in the positive direction, we're going to have 5, 6, 7, 8, 9. We're going to add 1 unit going to the right. And in our negative direction of our number line, we're going to subtract 1. So 3, 2, 1, 0, -1. X is less than or equal to 4, so less means we're going to shade to the left. Okay, when you are graphing inequalities, we're looking to see if the circle is open or closed. In other words, if it's filled in or not, if the shading is correct, and if ordering the numbers above that number and below that number are done correctly on the number line. Okay, it says our next question here is let's investigate the inequality x minus 3 is greater than -2. And they have started a chart here where they have plugged in the values for x, and they're solving x minus 3, what the answer would be, and then testing to see if it is greater than -2. So looking at if we have -4 for x, -4 minus 3, that's -7. Is that greater than -2? That is false. Okay, and then -6 is also not greater than -2, so that's false. All right, we have -2. -2 minus 3, that's going to give us -5. -1 minus 3 is -4. 0 minus 3 is -3. And what you'll notice on the chart is that we're really just adding 1 going to the right. So -3, this is going to be 1, this is going to be -2, -1, 0, 1 to fill in the chart. Then it says, which values of x is it true that x minus 3 equals -2? Well, if it's going to equal -2, x would have to be equal to 1 if we were using an equal sign. For which ones of these values would x minus 3 greater than -2? So we want an answer that's greater than, not equal to -2. That would be these values right here, because these are greater than -2, which would mean 2, 3, 4, and so on. So x is greater than 1. Okay, anything greater than 1 is going to give us a true statement. Okay, then it says to graph the solution for that. Well, we're basically graphing x is greater than 1. So we're going to put 1 in the center. And going in the positive direction, we're going to add 1 going to the right to set up our number line, which means we're going to subtract 1 going to the left in the negative direction. So 0, -1, -2, -3, -4. We have an open circle because there's no equal sign at the 1, and x is greater than, so that means we're shading to the right. In the positive direction would be that number and greater. Okay, predict which values will make the inequality true for 2x less than 6. So 2x is less than 6. Let's solve it. Divide both sides by 2, and because we're dividing by a positive number, our inequality does not switch directions. So we have x is less than 6 divided by 2 is 3 would be our solution. Down here for our table, what would be your prediction? Well, any value less than 3 would work. Okay, if x is -4, what would be 2x? Well, 2 times -4 is -8. 2 times -3 is -6. 2 times -2 is -4. 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. Okay, we're supposed to graph that solution of 2x is less than 6 on the number line, which we figured out was x is less than 3 from the previous work up top. So we're going to put 3 in the center. We're going to have an open circle at 3 because there's no equal sign to it. Over to the positive direction, we're going to add 1 going to the right to complete our number line. Over to the left, or towards negative infinity here, we're going to subtract 1. So 3 minus 1 is 2, 1, 0, -1, -2. It's very important to have equal size increments on our number line. Okay, x is less than 3, so less means we're shading to the left. So any number less than 3 would work for the condition. Okay, over to the next page. Now we have, here's an inequality. -2x is less than 6. So in order to solve this one, -2x is less than 6. We're going to have to divide both sides by a -2. And what we have to recall here is that when we divide by a negative, our inequality symbol is going to switch direction, because multiplying and dividing by a negative means opposite. And the opposite of a less than would be greater than. So -2 divided by -2 is 1. 1 times x is x. x is greater than 6 divided by -2 is -3. So predict what your answer would be there. It's going to be any value greater than -3. Okay, we're going to be filling in the table. Does it match your prediction? We're going to say yes here. -2 times -4 is +8. -2 times -3 is +6. -2 times -2 is 4. -2 times -1 is 2. Then we have 0 times anything is 0. 1 times -2 is -2, -4, -6, and -8 respectively. So we're saying that x has to be greater than -3. Yeah, because it can't be 3, right? If you have -3 here, 6 is not less than 6. So these two are false statements because you can't have 8 is less than 6. That's not true. And 6 is not less than 6. It actually equals it. And since there's no equal sign on it, that's not true. But 4 is less than 6. 2 is less than 6. So anything else is going to be true. So x has to be, the value of x has to be greater than -3 to work. And now we're going to graph that on the number line. X greater than -3. We're going to put -3 in the center. We're going to have an open circle at the -3 because it can't equal it. And going in the positive direction, if we add 1 to -3, we get -2, -1, 0, 1, 2. In the negative direction, we're going to get less. So -3 minus 1 is -4, -5, -6, -7, -8. And we have x is greater than -3, which means we're going to shade to the right. So x can be any value greater than -3, which is all of these. How are the solutions to 2x less than 6 different from the solutions to -2x less than 6? Well, they are opposite. And they are opposite because here you have a negative sign, which changes everything. If you have a negative sign, that is much different when you're multiplying a -2 times a number versus a +2 times a number. All right, the next section here, it says which side shows the solution. So we're looking at investigating -4x plus 5 is greater than or equal to 25. We're asked to go ahead and solve an equation here with the equal sign and then seeing what makes sense. So let's go ahead and solve the equation for this part right here. -4x plus 5 equals 25. Furthest away from x on that same side is a plus 5, so we're going to subtract 5 on both sides. That we get a 0 pair here for our plus and minus. So we're going to bring down our -4x, and then 25 minus 5 is 20. Our next step is to do the multiplicative inverse. X is being multiplied by -4, so we're going to divide both sides by -4. And x equals -5. So for this statement here, is this true when x equals 0 for this statement? Well, if I have 0 plus 5, is that greater than or equal to 25? Our answer is no, because 5 is not greater than or equal to -5. What about when x is 7? So if x was 7, and I work that out here off to the side here. Negative 4 times the quantity 7 plus 5. Is that going to be greater than or equal to 25? Well, I'm going to have negative 28 plus 5, which works out to be negative 23. That's not greater, so that's going to be no. What about negative 7? Well, negative 4 times negative 7 plus 5, that would be positive 28 plus 5, which 28 plus 5 gives us 33, so yes. So sometimes just testing positive and negative numbers will let you know if you need x to be greater than or equal to negative 5 or less than or equal to negative 5. So negative, which way do we want to think about that now? So it looks like the more negative your answer is the correct way to go. So we're going to say that x is going to have to be less than or equal to negative 5 if we're thinking about this in the correct direction. Because we notice that the 7 is not going to work. So we're going to actually work this equation out with the inequality symbol on the next page. If that didn't make sense to you, let's just work it out. Okay, so we're going to copy the equation. Negative 4x plus 5 is greater than or equal to 25. Using our inequality symbol, we're going to subtract 5 on both sides. That gives us negative 4x is greater than or equal to 20. And then when we divide by a negative 4 here, remember when you're dividing by a negative, your inequality has to switch direction because dividing or multiplying by a negative means opposite. So we're going to have x is less than or equal to, and 20 divided by negative 4 is negative 5. You'll notice that that's what we came up with on the previous page, but this is why that works. Okay, they want us to graph this, so we're going to put negative 5 in the center of our number line. It's going to be a filled in circle because it also equals. And now ordering our number line in the positive direction, we're going to add 1. So this will be negative 4, negative 3, negative 2, negative 1, 0. As we're adding 1, we're getting less negative and closer to the positives. In the negative infinity direction, we're going to have negative 6, negative 7, negative 8, negative 9, negative 10. And we knew that negative 7 was a solution to our work. And x is less than or equal to negative 5. So we know that we're shading in the correct direction because we tested it for 7 as well. Okay, let's investigate x divided by 3 plus 7 is less than 19. Step 1 is to go ahead and solve that. So we're going to rewrite the inequality. Oh, it's an equation. We have the inequality here, but they want us to do the equation first. All right, minus 7 on both sides. X divided by 3 is equal to 12. And then the opposite of dividing by 3, we're going to have to multiply both sides by 3. And we get x equals 12 times 3, which is 36. Is this equation true when x is 0? Well, 0 divided by 3 is 0. 0 plus 7 is less than 19, so yes. Okay, 0 plus 7 is less than 19. 7 is less than 19. Since it's a true statement, we can say yes. Okay, it says graph the solutions for this inequality. So we need to solve this inequality. We have x divided by 3 plus 7 is less than 19. We would do the same steps here. Subtracting 7 on both sides, x divided by 3 is less than 12. And since we are multiplying both sides by a positive 3, Okay, positive does not mean opposite, so we do not need to switch the direction of our inequality. We get x is less than 36. Okay, we're going to write 36 in the center. We're going to have an open circle, and less means we're shading to the left. Okay, ordering some numbers here. In the negative direction, we're going to subtract 1. So 35, 34, 33, 32, 31. Adding 1, going to the right and getting larger. 37, 38, 39, 40, 41. Okay, solve the inequality. 3 times the quantity x minus 4 is greater than 16.5. I'm going to work that out here off to the side. Greater than 16.5. Now they threw in a decimal. All right. I'm going to divide both sides by that 3. And it's a positive 3, so my inequality will not switch direction. I have x minus 4 is greater than, and then 16.5 divided by 3 gives me 5.5. Okay, the opposite of subtracting 4 is to add 4. So we get x is greater than 9.5. If I have a decimal here, 9.5. Since there's no equal sign, it's going to be an open circle. And this time I could go by ones, or I could go by halves, or I could go by tenths. So if I wanted to order tenths, 9.5, 0.1 more than that, if I'm adding 0.1, going to this direction, I would have 9.6, 9.7, 9.8, 9.9, 10.0. In the negative direction, I'd have 9.4, 9.3, 9.2, 9.1, and 9.0. X is greater than, so we're shading to the right. Now, if you wanted to go by halves, you'd have 9.5, 10, 10.5, 11, and so on. There's no rhyme or reason. I just decided since it had tenths that I would add 1/10 going to the right, and I would subtract 1/10 going to the left for my negative infinity to positive infinity going that way. All right, the next one, we have solved this inequality. Negative 2 times the quantity x plus 3 halves is less than or equal to 6. I'm going to divide both sides by a negative 2, which means my inequality is going to switch direction. X plus 3 halves is equal to 6 divided by negative 2 is negative 3. I'm going to have to subtract 3 halves from both sides. X is greater than or equal to negative 3 minus 3 halves is negative 9 halves, which is x is greater than or equal to negative 4.5. Or you can leave it as in halves if you want to do fractions on your number line. I'm going to do the decimal. I'm going to have negative 4.5 in the center here. I do have that equal sign, so I'm going to be shading it in. Greater than means shading to the right. And this time I will go by half. So this is negative 4.5. This will be negative 4 because I'm getting larger. This will be negative 3.5. This will be negative 3. Negative 2.5, negative 2. In the negative direction, or where it's less, I'm going to go to negative 5, negative 5.5, negative 6, negative 6.5, negative 7. Again, ordering my number line correctly. Okay, here it says, are you ready for more? We're going to skip that today. And you have your lesson summary there, which you can read on your own. And then we have some practice problems for homework. I'm going to get you started on this, and then you'll do the rest. So looking at this first homework assignment, it says -1 is less than or equal to x divided by 2. Again, if we want to solve for x, the opposite of dividing by 2 is to multiply both sides by 2. And if we multiply both sides by 2, we are going to get x by itself on this side. We're going to have x is greater than or equal to 2 times -1, which is -2. I could rewrite that because we would be reading in terms of x here. X is greater than this amount, so I can just rewrite it. Okay, there's the opening part next to x. X is greater than or equal to -2. So any number greater than or equal to -2 will work as a solution. Then it says to check your prediction. Well, we didn't predict, we actually worked it out. So if I had -4, -4 divided by 2 is -2. Here I would have -1.5. -2 divided by 2 is -1. This would be -1.5 because -1 divided by 2 is -1/2. 0 divided by 2 is 0. 1 divided by 2 is 1/2 or 0.5. 2 divided by 2 is 1. 3 divided by 2 is 1.5. And 4 divided by 2 is 2. Which values will make this true? So we're going to say any number -2 or less. Okay, that was the example I worked out for you. You are going to complete this right here for homework and these other questions back here. Let's go ahead and skip this one. Okay, the last question you can skip, but I do want you to practice drawing on a number line and then also checking for solutions that would work to this equation here. Okay, so you're just not doing question 6. You are doing questions 2, 3, 4, and 5 for homework.